Okay, so now let's talk about what a graph of a function looks like. And so a graph is really a collection of points with an x-coordinate and a y-coordinate. And the x-coordinate here is always corresponding to the input, and the y-coordinate here is corresponding to an output. And so every point on a graph is an input-output pair. And so just to frame this a different way, if I have some function f, and I have something like 2, 3 is on the graph of f, that means exactly the same thing as the statement that f of 2 is equal to 3. And so it's important for this course to be able to freely translate between 2 3's on the graph and f of 2 equals 3. These are identical statements that have identical meaning. It's totally up to you which you say, but you can always flip back and forth between them. So when we actually go to graph a function, what happens? Well, let's say I go to graph the function f of x equals 4 minus x. Well, and I can draw my little grid, and I can go ahead and evaluate the function at a bunch of points. So if I take f of 0, 4 minus 0 is 4. If I take f of 1, 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 4 is 0. All of these give me a corresponding point on the graph. This gives me 4, 0. This gives me 3, 1. And so if I were to sketch this graph, I could put all these points here. So remember, this is the x-axis, this is the y-axis. And so if I want the point 0, 4, I go to 0 on the x-axis and run up to 4 on the y-axis. So that would be 0, 4. As distinct from the point 4, 0, where I would run over to 4 on the x-axis and 0 on the y-axis. Okay, and I can fill in the others too. So there is 3, 1, there is 2, 2, there is 1, 3. All of these points are on the graph of this function precisely because they all correspond to these input-output pairs. And as you probably know, these aren't the only inputs I could take. I could take an input like a half and get 3.5, or an input like pi and get 4 minus pi. And so really, if I draw the whole graph, it actually is a line that passes through these points, as you're probably well aware. Right. And so this ends up being what our graph is. But every graph you see ends up telling you everything about these input-output pairs, exactly like it does here. Now, you're rarely, if ever in this course, going to have to do this where you plot a bunch of points to get a sense of what the graph looks like. And that's because I'm going to almost always include a graph for you. And even if I don't include a graph, you can pull up a graphing calculator or go to Wolfram Alpha or Desmos and pull up graphs. So even if I don't personally give you a graph, which I usually do, there'll still always be a graph available to you just by typing something into your web browser. Now, there's some particular points that are special. Namely, we like to identify points where the graph hits the y-axis and points where the graph hits the x-axis. So these are called X-Intercepts. These are called Y-Intercepts. And so one of the most common questions on the homework throughout the semester will be, given a particular function and a particular graph, what are the coordinates of the X-Intercepts and the Y-Intercepts? So that's the X-Intercept. That's the Y-Intercept. And I want to highlight for you that there is immediately a source of confusion here, because the X-intercepts are the points where y is 0, not where x is 0. Likewise, the Y-intercepts are where x is 0. So the fact that these are backwards of what they might be in a just universe is a source for a lot of confusion. So make sure you're very careful when you look at this that you're really labeling a point 4, 0 if it's 4, 0 and not 0, 4. It's easy to swap them around. I also wanted to quickly interpret what X-intercepts and Y-intercepts mean in terms of inputs and outputs. So remember, the Y is the output. So X-intercepts, these things actually correspond to a 0 output. So these things correspond to inputs with a 0 output. On the other hand, Y-intercepts correspond to places where X is 0. So that is, Y-intercepts, these correspond to the output corresponding to the input 0. And I'm going to go ahead and spoil it right now. When I talked about the definition of a function, I talked about how every input got transformed into only one output. Well, the input 0 is no different, which means that the input 0 is only going to give one output, which means there's never going to be a plural Y-intercepts. There's only going to be at most one Y-intercept. On the other hand, there can be lots of X-intercepts, as we'll see in a moment. All right, so here's a graph of a function g of x. And I want to point out that just by looking at this graph, we can already figure out how to evaluate this function at a bunch of points. So if I ask, for example, what's g of 2, I can figure that out from this picture. Okay. Again, this 2 is an input. Inputs are on the x-axis. That's my input of 2. And so I can read up here, and I see the point 2, 3 is on the graph. And so this 3, that's my output. So g of 2 here is 3. Likewise, if I take something like g of negative 2, then I correspond, again, over to the x-axis. There's my negative 2 right there. And so I see the point negative 2, 0 is on the graph, which tells me that the output corresponding to the input negative 2 is 0. Note that this statement, by what we said before, I found an input whose output is 0. This exactly corresponds to the statement that minus 2, 0 is an X-intercept. Likewise, if you want to think about the Y-intercept corresponds to the input 0. So I can look at the input 0, find the output that matches the input 0, which is 1. So g of 0 is 1, and so this corresponds to the statement that 0, 1 is the Y-intercept. Notice negative 2, 0 is not the only X-intercept. It's also the case in this graph that 3, 0 is an X-intercept. The most important thing here to be careful with is that whenever you're evaluating one of these things from the graph, g of 2, g of minus 2, g of 0, whatever, whenever you're evaluating one of these things from the graph, you want to make extra sure that you're looking up the input on the x-axis and not the y-axis. Because, for example, when I look at g of 2, there's two 2's I can look at, but looking at this 2 will not help me. Looking at this 2, in fact, will only harm me. And so I have to make sure I'm looking again for inputs on the x-axis, which corresponds to inputs. Okay. The y-axis is for outputs.